Woven wire mesh is among several of the screening media used during the molded pulp process. Its ability to facilitate even heat and pressure distribution while offering optimal cut points and flexibility make the material stand out. Now, several steps must be taken to ready wire mesh for molded pulp applications. One critical step that often gets overlooked is annealing your wire mesh. But what exactly does annealing wire mesh mean, and why is it such an imperative step? Annealing is a heat treatment process that lowers the internal stress of the wires in the weave. This causes the mesh to become softer, making it much easier to form into pulp molds. Annealing is most commonly carried out using one of two techniques: batch annealing and continuous annealing. Batch annealing involves placing rolls of wire mesh into a specialized capsule and submerging it into a furnace. This capsule is designed to create a complete seal and subject the mesh to vacuum pressure once placed in the furnace. The mesh is then heated to a specific temperature for a specific amount of time. Once done, the mesh is removed from the furnace and left out until completely cool. Continuous annealing involves the wire mesh supplier taking a wire mesh roll, unrolling it, and passing it through an oven-like furnace. Since it's a lot harder to control than batch annealing, the unrolled mesh will typically pass through the furnace several times to ensure a thorough annealing. Woven wire mesh is placed on top of the mold and helps to facilitate the molded pulp process. When used correctly, the mesh allows optimal water drainage and ensures heat as well as vacuum pressure is distributed evenly. In order to fit snugly on a metallic mold, wire mesh must be deep drawn to take on the profile of the final molded product. While wire mesh is relatively pliable off the loom, capturing finer details of a mold can prove challenging. Annealing ensures your wire mesh can be formed to replicate even the most detailed molds. It does so without altering the process or characteristics of the pore openings of the mesh, which is pretty important. Failure to properly anneal wire mesh for molded pulp applications will often lead to mold springback. Springback happens when the wire mesh lacks structural integrity, struggles to hold the form of the molds, and begins reverting to a flatter profile. Annealing your wire mesh can help improve the rigidity of your pore openings. Non-annealed wire mesh will be more sleazy and flimsy, which will impact the fiber retention and ultimately efficiency of your molded pulp process. So, put simply, implementing wire mesh that has not been properly annealed can lead to costly inconsistencies in the final molded pulp products. Thanks so much for watching. If you have any questions, click our Talk to Us button and get in contact with our many experts on woven wire mesh. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. We also have a YouTube channel. And don't forget to click that subscribe button and ring that bell to keep up with all things WS Styler. Once again, my name is Andrew Kotlar, and I'll see you around in the next video. Bye for now.